Today we are moving on to log and exponential equations and inequalities. So we are going to be using all of the same properties to solve these inequalities, but we want to make sure that our final answer is in the domain of all expressions within the original problem. So our first step, we're just going to write down some general steps to follow. So off to the side, I'm going to write those down. All right, so our first step, if we are working with log or natural log, then you're going to find the domain first. So find domain of log or the natural log. And this just means that we're going to, whatever is in the parentheses, we're going to make sure that that is greater than 0 because we cannot take the natural log or log of a negative number. So parentheses needs to be greater than 0. Our second step is going to be to change the inequality to an equal sign and solve. So change inequality to equal sign and solve. Okay, and then the parentheses stays on the side it starts. So the parentheses stays on side it starts when changing from log to exponential form. Okay, number 3, we're going to test points to make sure that our solution is not extraneous. And then our last step is going to check against the domain. In number 1, we are saying that 3 times 2 minus 0.6 raised to the power of x is going to be less than or equal to 1. So we can skip our first step since we don't have log or natural log. Okay, next we can go ahead and solve for x. So I'm going to divide both sides by 3. So I have 2 minus 0.6 raised to the power of x is less than or equal to 1/3. Okay, I'm going to subtract 2 from both sides. So I have negative 0.6 raised to the power of x is less than or equal to negative 5/3. Now I want to change negative 0.6 to be a fraction. So that is going to be negative 3/5 raised to the power of x is less than or equal to negative 5/3. Okay, now I'm going to multiply through by a negative 1. So I have 3/5 raised to the power of x. Make sure when you divide by a negative, we change our inequality sign. We have to flip it. So now it's greater than or equal to positive 5/3. Okay, now if we recall from a couple days ago, we want to have the same base and then we can solve for our exponents. So I can make the same base if I just switch 3/5 raised to the power of x to be 5/3 raised to the power of negative x is greater than or equal to 5/3, and this has the power of 1. So since I have the same base, now I can just solve for x, or I'm sorry, I can just ignore the base and solve. So I have negative x is greater than or equal to 1. So then I have x is less than or equal to negative 1. Okay, so that's going to be my solution, and you can test a point in to verify that it works. In number 2, we have the natural log of 2 minus 5x is greater than 2. Since we do have the natural log, we first want to find out the domain. So I'm going to take 2 minus 5x and make sure that that is greater than 0. Let's solve for x. So we have negative 5x is greater than negative 2. X is less than 2/5. So make sure that you do flip your inequality sign. And then once we solve this inequality, we do want to double check our final answer to make sure that it satisfies this domain. Okay, so we are going to convert this logarithm into an exponential form. So by doing that, I am going to end up having, I'm going to switch colors here. I have 2 minus 5x is greater than e raised to the power of 2. Okay, then I can go ahead and isolate my x. So I'm going to have negative 5x is greater than e squared minus 2. Let's divide both sides by negative 1. So 5x, flip your sign, is less than negative e squared plus 2. I'm just going to rewrite that as being 5x is less than 2 minus e squared. Okay, so then x is less than 2 minus e squared all over 5. Okay, you can leave your answer like that, or you can go ahead and put that into your calculator. If you do, you will end up having x is less than negative 1.078. Okay, so either one of these answers would be fine, unless it specifies to round to a certain number of decimal points. We do want to verify that that satisfies our domain. So our domain said that x has to be less than 2/5, and we ended up having x is less than negative 1.078. So that does satisfy this domain. Number 3, we have log base 2 of 2x minus 1 divided by x minus 2 is less than 0. Okay, it's important to note that the logarithm of a fraction is going to give us a negative number. So log of a fraction is negative. Okay, and that's important to note since we have that it is less than 0. Okay, so that means that we need 2x minus 1 over x minus 2 to be in between 0 and 1. So I have 0 is less than 2x minus 1 over x minus 2 is less than 1. So that's going to ensure that we have a fraction. Okay, so let's take each part and solve them separately. So first I'm going to have 2x minus 1 over x minus 2. We have that is greater than 0, but remember we're going to change this to an equal sign, but let's not forget that it was greater than. So then I'm going to have 2x minus 1 is equal to 0. 2x is equal to 1. So x is equal to 1/2. I also have x is equal to 2 because the denominator cannot be negative. Okay, so then we're going to test our values. So here I have 1/2 and I have 2. Okay, but I'm going to test some values in between. So I want to test 0, I'll test 1, and I'll test 3. So if you substitute in 0, we get a positive number. If you substitute in 1, we're going to get a negative number. And if we substitute in 3, we will get a positive answer. Remember that originally we had 2x minus 1 over x minus 2 is greater than 0. So we only want to include our positive answers. Okay, so I have x is less than 1/2 or x is greater than 2. Now we will repeat with our second inequality. So we have 2x minus 1 over x minus 2 is less than 1. So I have 2x minus 1 over x minus 2 minus 1 is less than 0. 2x minus 1 over x minus 2 minus x minus 2 for x minus 2 is less than 0. Now we can just simplify since we have common denominators. Be careful with that negative. You have to distribute that negative. So we will end up having x plus 1 all over x minus 2 is less than 0. So now I'm going to have x plus 1 is less than 0. So x is less than negative 1. Okay, but remember we're going to change, instead of having that inequality symbol, we're going to change it to equal to. So x is equal to negative 1. And then I also have x is equal to 2 since I cannot have a denominator that's less than 0. Okay, then let's test our values. So here's my number line. Okay, I'm going to have negative 1 and I have 2. So right here would be 0. So I'm going to test a number that's smaller than negative 1. I'll test 0, and then I'll test a number that's larger than 2. So remember, we are only looking for numbers that'll satisfy being less than 0. So we're only looking for negative numbers. Okay, so if we substitute in -2, we're going to end up with a positive answer. If you substitute in 0, we will get a negative number. And then if you substitute in a number greater than 2, we will get another positive. So our only solution set is going to be in between -1 and 2. Okay, so we have x must be greater than -1 or x must be less than 2. Okay, so at this point we have 4 different inequalities. We have x is less than x is less than 1/2, x is greater than 2, x is greater than -1, and x is less than 2. So we need to put all of these together to determine our final solution set. So let's combine all of this onto one number line. So I am going to have my -1, 1/2, and then 2. Okay, now I'm going to use the same color so that we can see what is going on. So at 1/2, x is less than 1/2, so I would be shading this way, or x is greater than 2, so it would be going that way. Okay, our second set says that x has to be greater than -1, so that's going this way, or x is less than 2. So our last step is just to determine our solution set. Well, we can't have x is greater than 2 and x is less than 2. That doesn't make sense. So the only area that overlaps that satisfies all of these inequalities is going to be between -1 and 1/2. So our solution set is -1 is less than x, which is less than 1/2. Moving along to number 4, we have e raised to the power of 1 over x minus 1 is greater than 1. Let's take the natural log of both sides. The natural log with e cancel out, so I have 1 over x minus 1 is greater than the natural log of 1. It just comes out to 0. So now I have 1 over x is greater than positive 1. Let's multiply both sides by x. So then I'm going to end up having x is less than 1. Okay, but in our original problem, we have x as being in the denominator, so we cannot have a negative number. So our final solution is going to be 0 is less than x, which is less than 1. For the last two problems, we're going to be solving the following equations for x in terms of the other variables. So number 5, we have y equals a times e raised to the power of kx. So we want to solve for x. So first I'm going to divide both sides by a. So y over a is equal to a raised to the power of kx. Then we can take the natural log of both sides. So I'll have the natural log of y over a is equal to kx. Remember that the natural log times e just cancels out. And now I can divide both sides by k. So I'm going to end up with 1 over k times the natural log of y over a is equal to x. And then I have x by itself. In number 6, we have alpha times the natural log of x plus the natural log of beta equals 0. So I'm going to first, since we're trying to solve for x, I'm going to move the natural log of beta over to the other side. So I have alpha times the natural log of x is equal to negative natural log of beta. Then I can divide both sides by alpha. So I'll have the natural log of x is equal to the negative natural log of beta divided by alpha. Then I'm going to multiply both sides by e. So on the left-hand side, it's going to cancel out, and I have x is equal to e raised to the negative natural log of beta divided by alpha. Okay, now this negative I'm going to bring over here. So if I do that, I'm going to have x is equal to e raised to the natural log of beta raised to the negative 1 over alpha. Okay, so now that E and the natural log cancel out, so I'm left with x is equal to beta raised to the -1 over alpha.